All right, so today we're going to be talking about the graphing continuity. So that's the top part up here, what continuity is, and we might do a few graphing problems and whatnot. I'm looking real quick to see if I put any graphing. Yeah, I'm going to do a few of them just for time's sake for tomorrow. Okay, so a continuous graph is a graph that has no jumps or breaks. So like if I was drawing a graph and I drew it like this, and that would be continuous because I didn't have to pick up my pencil. So this one right here, that's not continuous because I had to pick up my pen to go from one part of the graph to the other part of the graph. So there's a much more sophisticated definition when you get into higher level math, but for now, that's good enough for you to know that if you have to pick up your pencil, then it's not continuous. So how do we find the points of discontinuity? So there's two types of discontinuity you can have and that we can find algebraically. So the first one is a point that removes. Second one is non-removable. We usually call this just an asymptote on there. So I have two examples to show you what it is. So when I factor the top and bottom and this cancels out, what really happens here, you guys, is it creates a hole. And if you're in class, you get to hear a whole story about the space shuttle that blew up because a math mistake like this happened. So a hole is created. So x does not equal -2. That's where the hole is. And then over here, this is just a vertical asymptote. So right here, we call this a vertical asymptote. So if it is a hole, it is a removable point, which means just one point isn't there. And then this is a non-removable point. It's an asymptote. Typically, it's what we call it. But this book that we had used calls them removable, non-removable. So down here, I'm going to find the domain, points of discontinuity, x and y intercepts of all of them, and then determine it. So first, let's just do discontinuity because that's what we just learned. So discontinuity, make sure the top and bottom are factored. So top can't factor here. The bottom factors into x minus 2. So then that gives me 0 and 2. Since you cannot cancel those out, those are both going to be non-removable points. So they're vertical asymptotes. So non-removable would be at 0 and 2. So this one right here, factor your top and bottom. So the x minus 1 is going to cancel. So I'm going to have a hole where I canceled. So this is called a removable point. The holes are removable where x is 1. And then the non-removable points are your vertical asymptotes. And that's at -1. So this one right here, I'm going to factor out a -3 just because I never like my x to be negative. It never helps you. So if I take out a -3, I get x minus 2. So cancel these out. So we're going to have a removable point that's a hole where x equals 2. Non-removable is at your vertical asymptote of x equals 3. So we still exclude these out of our domains. So if I wanted to do the domains, I still exclude removable and non-removable points. So like the domain for this one would be -infinity to 0, 0 to infinity, 0 to 2, 0 to 2, 2 to infinity. So here you'd say -infinity to -1, -1 to 1, 1 to infinity. And you should put the u's. I was just being lazy right there. So the domain here, so -infinity to 2, 2 to 3, 3 to infinity. So then the only things we haven't practiced yet are your x and y intercepts. So I'll go ahead and do number 1. The top will not equal 0 on this one. So we are not going to have an x-intercept. So there's no x-intercept. Y-intercept, if I plug in 0 for all those, I get... I'd get 0. I'd get 5 over 0, which means there's no y-intercept either because you can't divide by 0. So 1 had no x and y-intercept. 2, set my top equal to 0 here. Oh, I can't set the top equal to 0 because that was the removable point. So again, there's no x-intercept. And then the y-intercept, if I have 3 over x plus 1, and no matter where you plug it in, you can plug in the 0 here or the 0 here. It's the same answer each time. You get a y-intercept of 3. right, and then number 3, set the top equal to 0. I can't because it canceled out. So then my y-intercept would be plugging in zeros. I get 6 over 6, so I get 1. So that's the only y-intercept for these. So we're going to graph about 2 or 3 of these in this lesson, and then tomorrow we're going to finish up the rest of the lessons. So to graph these, there's all kinds of stuff to do in the general form. So first thing I always do is I find my asymptotes, and I find my x and y intercepts. If there's no horizontal asymptote, I'll explain that when we get to it. It's an end behavior. And then we will test our asymptotes to see what's happening. The reason I like testing is because it's relevant on higher level math, but you can always try points too if you don't understand the testing. So number 1, if I find all my asymptotes, I'm going to find that first, and I'm going to graph on a separate sheet of paper I have over here. So I'm going to say my vertical asymptote is bottom equal to 0. Horizontal, I'm going to follow my rules, so that gives me 1. My x-intercept is set the top equal to 0, so I get 0, 0. Remember, if your x-intercept is 0, 0, sorry, I don't know why it keeps losing focus. I think the thing just hates me today. So you get 0, 0 if that. So I'm going to go ahead and find it for number 2 also, and then we'll bring over our paper. So don't forget, you have to factor your top if it factors to make sure it doesn't cancel with your bottom and create a hole. So it doesn't. So then I'm going to do my vertical asymptote is bottom. Horizontal asymptote, top was bigger, so we're going to have a D and E. Oh, this is going to see what happens when we have a D and E here. And then x-intercept is top equal to 0. Y-intercept is when I plug in 0. All right, so now that I have all my stuff, I'm going to go ahead and graph some of these. So number 1, I'm going to go ahead and plot all my asymptotes. And 0, 0. Since this is 0, 0, most likely my graph is in the top left, top right, and then in the middle. But we can check them just to make sure. So what you do in order to check these is I'm going to pick a number a little bit smaller and larger than each of my asymptote, going smallest to largest. So I'm going to test negative 0.01, negative 0.99, 0.99, 0.001. So if you need to, you can go ahead and grab a calculator out and then just type it in and make sure you just type it in correctly. So I would type in like negative 1.001 squared divided by negative. Make sure the whole bottom has a parenthesis around it if you're going to do it this way. So that's a positive number. Okay, so you can do that for all of your numbers. What I like to do is I like to think it through, and I'll show you this for this one. So if I do a square on top, it's positive because I squared it. A number smaller than 1 squared minus 1 is going to come negative. So positive divided by a negative is negative. 0.99. Positive on top. Again, squaring it minus 1 will make it negative. Plug in 1, square it's positive. A number bigger than 1 squared minus 1 would still be bigger than 1. So then that's a positive. So I have a plus, minus, minus, plus. What this means now is the direction that you're pointing. So on this side, I need to point to positive infinity. That's why it's pointing up. In the middle, they both point to negative infinities. And to the right, I'm going to point to positive infinity. So it goes up there. Okay. So for number 2, when we graph, I'm going to fold my paper. So for number 2, I'm going to plot my vertical asymptote. So when there's no horizontal asymptote, I have to do end behavior. And all that means that you divide the highest on top with the highest on bottom, and you get what your behavior is going to look like. So if I do x squared divided by x, that gives me an end behavior of y equals x. And it's almost always y equals x, a half x, 2x, negative a half x. So all you're going to have is a dotted line. And there's actually, like, you could move this up and down, and you'll learn that next year in your class. You have to do long division, which we don't do. So we're going to leave it like just always go through 0, 0. So I'm going to test my vertical asymptote, which means I need to test my point 1.9 and 2.1. So I'm going to plug it into the top here, 1.9 minus 1, 1.9 minus 1, divided by 1.9 minus 1. So if I multiply or divide 3 negatives, my end result is a negative. 2.1 will be, oh wait, that's positive on top, so I'm dumb. 1.9 minus 1 is a positive number. All right, so we get positive, positive, and then on bottom, 2.1 minus 2 is a positive 0.1, so positive. So they're all positives. That tells me on the left side of the dotted line, I need to be pointing down to negative infinity down here. And then just follow your dotted lines. Oh wait, I have an x-intercept at 1. I forgot to plot my intercepts. Sorry guys. Make sure you plot your intercepts if you have them. And then I'm going to go through there. So those dots would have given us a pretty good clue that it should be down here. Okay. All right, I'm going to do the rest of the graphing ones tomorrow.